Okay, so let's start with chapter 1. That's the counting techniques. Now, counting techniques, we have done this for advanced level, a part of it. So this will be like a review for you. So we have done combined mathematics for advanced level. You have already done these techniques, but there are maybe few new things that we are going to cover. Okay. So under counting techniques, we are going to look at 3 different techniques. The first one is the basic principle of counting or the multiplication rule. Next, we have the permutation and then the combinations. Okay, so those are the 3 main topics we are going to look at. The basic principle of counting, that is actually the multiplication rule. And then we have the permutations and the combinations. Right. Now, why do we need these counting techniques? So what are we trying to do with these multiplication rules, the permutation and combinations? What we are trying to do is, when there are several ways of doing the same task, we want to know how many different ways that we can actually do it. Right? How many possible ways, all possible ways that we can do a task when the task can be divided into subtasks, and each of these tasks can be done in many different ways. Okay? So as an example, suppose you are planning a certain an event, and it has sub-events. Each sub-event can be done in different ways. The first sub-event can be done in 4 different ways. The second sub-event can be done in 2 different ways. Third sub-event can be done in 5 different ways. So likewise. And suppose you want to know all possible ways of doing this final task. Right, all possible ways, all different combinations actually, right? All different ways that you can do a certain task. Then there are subtasks, and these subtasks have different ways of doing it. Okay. The need of this, or need of trying to find all possible ways, right? If you can think about the basic need of doing such a thing is cost, right? If you are trying to figure out the budget for your event, so how much will I need to complete the first subtask? How much money do I have to allocate to complete the second subtask? Likewise. And when you are doing it, what is the cheapest way, or what is the most cost-effective way to complete the first task? What is the second most cost-effective way to complete the next task? Or what is the fastest way to do it, right? It can be the money, or it can be the time, it can be the human resource, right? So what is the easiest way that I can do? Maybe cost-wise, maybe the time-wise, maybe the human resource-wise, right? So unless you do not know all possible ways you can do it, how do we know what is the cheapest one? Maybe you have missed few combinations, then maybe one of those combinations give you the least cost or least time, the optimum way to do it, right? So in order to estimate such things, you have to know all possible ways that you can do it. Then only you can do the estimates, find out the cost that you will need for each and every possible way, or the time that you have to spend to complete each possible way, or the number of people you need to complete each possible way, right? So in order to do such estimates, it's always good to know that all possible ways that you can do it. If you think about it in more complex manner, when you think about production lines, simulations, right? In factories, right? If you want to figure out the optimum way to do a task, or optimum way to allocate people to certain tasks, or the most cost-effective way, or the most fastest path that you can finish a certain task, you should know all possible paths, and then you have to estimate the time, and then only you can figure out, okay, out of these 100 possible combinations, the 50-second one is the fastest track. Right? Okay, yeah, likewise, we can figure out those things by identifying all possible ways we can do it and then estimating maybe the time, cost, or the human resource. Okay, so those are few areas where you will be using these counting techniques, right? There can be many. You can think about them leisurely, right? Maybe in your day-to-day life, you already use these counting techniques without even knowing it, right? Without even knowing it, maybe you are already using these techniques to figure out the optimum way to do a certain task, right? Okay, so let's start with the first theorem that's related to the basic principle of counting or the multiplication rule, right? So here's the first theorem. So I have used the numbering 1.1, that is the first theorem in first chapter, okay? So what does it say? Go over, read it and get the idea. If an operation consists of two steps, now this is for the this is the basic definition or the basic of the theorem, but you can extend it, right? So let's start with two steps. If an operation consists of two steps, of which the first can be done in n1 ways, and for each of these, the second can be done in n2 ways. For each of these, right? The second can be done in n2 ways. Then the whole operation can be done in n1 times n2 ways. That is the multiplication, n1 times n2 ways, right? So when we say an operation, it can be a procedure, a process, a method, or a selection, right? Any task, right? So what does it say? If you have an operation or a task that consists of two subtasks or two steps, and suppose the first step can be done in n1 different ways, and the second step can be done in n2 different ways, then as a whole, the whole operation or whole task can be completed in n1 times n2 ways. Okay, let's try an example, right? So if you go with this first theorem, right? Let's say you go to a cafe, right? You go to a cafe and they offer you a snack and a drink. They offer you a snack and a drink, okay? So there are several packages that you can choose with. Suppose they offer you 5 different snacks. Okay, give me some snacks. I'll start with sandwich, cutlet, lavalier. Give me 2 other snacks that you'd like to add here. Anyone can join and give me 2 snacks that you like. Right, who want to add? Anyone, please. Add your favorite snack here.
Egg roll.
Egg roll. Okay. Anything else? One more?
Fish bun.
Fish bun. Okay. Right. So we have the 5 snacks, okay, offered in the cafe. Okay, what about drinks? Okay, I'll start with orange juice, tea. Let's add 4 of them, right? So 2 more drinks. Who wants to add a drink? Come on. Think about 2 drinks, 2 more drinks.
Faluda.
Faluda, okay. One more. Apple juice, okay. Right. So how many different packages that you can select? So let's say this is our step 1, selecting the snack. Step 2 is selecting the drink. What is N1? How many different ways that you can do the stack step 1? There are 5 possibilities. For the drink, that is N2. Second can be done in N2 way. What is N2? 4. So altogether, how many possible snack drink combinations that you can get from this cafe? N1 times N2. So that will be 5 times 4, 20. So 20 different ways that you can order a snack and drink. Well, if you know the prices, right? You know how much money you have to spend on each combination, right? What does that mean? You can go sandwich with orange, sandwich with tea, sandwich with faluda, sandwich with apple juice, lavery and orange juice, lavery and tea, lavery and faluda, lavery and apple juice. Okay, so likewise, each of these snacks can go with each of these drinks. So that is how you got 5 times 4, 20. So next time you go to the canteen, right? You know how to think about the number of ways you can order a snack and a drink. Not only that, even your lunch, right? Well, we'll look at them later, right? Okay, so this is not hard, right? This is not hard, very simple calculation. Okay, so here's the justification for the theorem. Now, since you already looked at the example, this is not hard. So you have x1 up to xn1. So this is our first step. X's represent the possible ways that you can do the first step. Y represents the possible ways that you can do the second step. So x1, x2 up to xn1, there are n1 possible ways. Then the second one, y1, y2 up to yn2. So you can write down all possible combinations. X1 goes with y1, x1 goes with y2, x1 goes with y3, and all the way up to x1 and yn2. So these are the couples actually, right? That you can go with x1 and all y's. Similarly, you can do the same with x2. With y1, x2 with y2, and x2 up to yn2. Likewise, you can write down all the couples, x1s and xi's and yi's, for all n1 of x's with all n2 of y. Right? So if you count these things, you will end up with n1 times n2. Right? So this is exactly what I explained here. Sandwich with orange juice, sandwich with tea, sandwich with faluda, sandwich with apple juice. So there are 4. Then you do the same with cutlet, cutlet with orange juice, cutlet with tea, cutlet with faluda, cutlet with apple juice. Now 4 plus 4, 8. Likewise, you get that 5 times. So you get 5 times 4, 20. Right? So this is how it has been done. Okay. Is that clear to all of you? Shall we move on to an example? Right. So try this one. Suppose that someone wants to go by bus, by train, or by car. Right? So that is the mode of transportation, by bus, by train, or by car. Those are the 3 choices. On a week's vacation, one of the 5 cities. So he can either try Anuradhapura, Polonnaruwa, Kataragama, Galle, or Bandarwal. So those are the 5 choices this person has as the destination. Right? So he can either go to Anuradhapura, Polonnaruwa, Kataragama, Galle, or Bandarwal. He can either go it by bus, by train, or by car. Find the number of ways in which this can be done. Right? So identify step 1, identify step 2, what is n1, what is n2. Simply you can do n1 times n2. Right? Do it quickly and tell me the answer. I'm getting the answer. It's not hard. Can do it by head, right? Yeah. So here's the answer. I got it. Many of you have answered in chat. So the mode of transportation, that is my first step. Step 1, identify the mode of transportation. I have 3 of them. So my n1 is 3. And the destination is the step 2, selecting the destination, right? And there are 5 choices for that. So n2 is 5. right? So you have n2 times n2, n1 times n2, which is 3 times 5, 15, right? So that's not hard, right? Here's another one. How many possible ways are there when we roll a pair of dice? One is red and the other is green, right? So this is a 6-sided dice. So each dice has 6 sides, you know that, 1, 2, 3, 4, 5, up to 6. So you have 2 dice, 1 red and 1 green. If you roll these 2 dice together, how many possible outcomes are there? Yeah, again, it's not that hard. You have 6 times 6, 36, right? If you want to write down it, you know, with the red dice and the green dice, x1 and x2, sorry, xi and yi, right? You can write down the combinations, right? These are the 6 possibilities for the green. These are the 6 possibilities for the red. So you can write down the tuples, right? Like this. 1 green with each of the faces in red. Second with each of them, right? And the third. So you can do it all the way up to 6, right? 6. So you'll see, you'll end up with 36 possibilities, right? And well, we'll come back to this example in next chapters also. We can do a lot of things using this type of experiment. Okay, right. Now let's extend this theorem to include more than 2 steps. So now this is the generalized version of the theorem 1.1. Now you have k steps, any number of steps, k, right? If an operation consists of k steps, of which the first can be done in n1 ways, the second can be done in n2 ways, third can be done in n3 ways, and it continues. So the k step can be done in, let's say, nk ways. If so, how do you write all possible ways of doing it? N1 times N2 times N3 times all the way up to Nk, right? So that will be N1 times N2 times N3 times up to Nk. So if you write this in notation, you can write it as Ni, I going from 1 to k. So this is the notation for the product, right? So, you know, the summation like this, right? This is for the summation. I use this for the product, right? So you can write down multiplication as a, in this notation, product of Ni I from 1 to k, right? So here's an example. Answer is there. The quality control inspector wishes to select a part for inspection from each 4 different bins containing 4, 3, 5, and 4 parts respectively. And so you can see that there are 4 bins. So let's say this is bin 1, bin 2, bin 3, and bin 4. So the bin 1 contains 4 different types of components. I have used different shapes. The second bin contains another set of components, and there are 3 of them. Third bin contains 5 different components, and the fourth one, 4 of them, right? So if you want to think about how many different ways that you can choose one from each, right? You want to inspect, so you choose one from each bin. So how many different selections or combinations that you can get? You can't use the combinations here since we are choosing just one, right? If you think about the definition of combination. Just think about all possible different ways of selecting one component from each bin, right? Select one component from each bin. So you can have 4 components from bin 1, 3 components, 3 possibilities or 3 choices for bin 2, 5 choices for bin 3, 4 choices for bin 4. So you multiply all of them 4 times, 3 times, 5 times 4, you get 240. Got it? Right? So that's not hard, right? Right. So let's try a practical example. Okay. Now, how old are you? 23, 4, right? Let's get 24 years old. So maybe in 3 or 4 years, you will be planning your wedding, right? So there's high probability that you'll be planning your wedding in 3 or 4 years from now. Let's say 4 years, okay? So what do? You have to go to the hotel and look at the menu, right? So that's going to be a hectic task, right? So when you are trying to do that, that's going to be a hectic task. Right. So when you go to a hotel, they will give you all different, things that they are going to offer, right? Different types of rice, different types of curries, different types of fries, different types of meat, different types of salads, different types of desserts, and some more complement items, right? Okay. Now you want to pick a menu, right? You want to tell, okay, I want this type of fry, this type of curry, this type of fries, this type of meat, and so on. Now suppose you are going to add just one from each, right? You are not going to select many rices, many curries, many fries, many meats. No. You are going to choose only one from each, right? So that's the rule, right? Only one from each, right? Okay. Suppose they have white rice, yellow rice, vegetable fried rice, whatever, seafood fried. So those are the 4 types of rice. And they have 3 different curries: bean, cashew nut, well, you can't forget dal, right? And fries, let's say potatoes and mushroom. And meat, let's say chicken, beef, pork, fish also, let's say. And salad, egg salad, and vegetable salad, dessert, cut fruit, ice cream, butter lapang, curd, whatever, jello. Right. Okay. So if you are going to choose one from each, how many different menus that you can ask for? Do the calculation and tell me the answer. You are going to choose one from each. One rice, one curry, one fry, one meat, one salad, one dessert. Have you ever thought that you can go for that many different possibilities? Even when you, walk through the buffet, have you ever thought that this many different possible ways that you can get your lunch. 960, right? 960. See how huge it is, right? So to get an idea about all possible ways that you can go for, right? So you can apply this rule and figure it out. 4 from rice, 3 from curry, 2 from fries, 4 meat, 2 salads, 5 desserts. So if you multiply this, you get 960, right? So it's not easy to plan a wedding, right? This is when you select only one. Now, usually we don't do that, right? We may be selecting 2 or 3 different rice, 2 or 3 different curries, 2 or 3 different meats, right? Several desserts. So imagine how many different combinations you can end up with, right? And if you are planning the budget, so you have to do the calculation for all of them. Okay, how much will be the first menu? How much will be the second menu? You know, likewise, right? So, well, there will be conditions applied, but now you can, well, start planning now, right? So it will be easy for you when it comes to actual wedding, right? Okay, right. Now I need an example from one of you, where you can use this multiplication rule in your real life. You can unmute and say, it's okay if it's, you can always modify or add things, define it, right? So one can start, then you'll add things and, come up with a nice example, right? So think and share an example where you will be using in your day-to-day life, where you will be using multiplication. May I name someone? Or you want to volunteer? Subject combination, very good. Yeah. Subject combination. Excellent example. Now, hypothetical situation, right? So not all the combinations are available, but let's see, right? Now the thing is, you can choose only 3 subjects, right? So when you have lot of different subjects, let's add few more, right? When you have lot of different other subjects, right? And you have to choose only 3 out of them. That is what we are going to learn in combinations, right? So selecting a subject combination in the real world, situation in our faculty or any other faculty, in other universities, the multiplication rule will not be the best way to do it because of the restrictions that we have in our predefined course combinations. Okay, so we'll do that in when we do the combinations. Okay, that's the third type of counting techniques. But since you gave me this example, we'll think about selecting the courses for a certain semester, right? So I'll modify your example because this is a very nice example. So I'll modify your suggestion a little bit, not the course combinations. We'll select the courses for the semester, right? So apologize me, I'm going to drop this side, the biology side, or we'll do it later, right? So suppose a person with combinations somehow that this person can get one subject from each of these, right? Suppose there are 3 subjects offered by that department, 4 subjects offered by the computer science, 2 from mathematics, 4 from chemistry, and 3 from physics. And so for a certain semester, suppose the students need to take one from each department. So how many possible ways that he or she can choose the list of courses? right? So not the combination, the list of courses for a certain semester, right? So 3 from stat, 4 possibilities or 4 choices from CS, 2 choices from maths, 4 choices from chemistry, and 3 from physics. So you can do the multiplication and find it, right? So let's do the same for the another set, right? So this is for physical. Let's say for the biology set, we can do, yeah, I'm getting the answer, right? 288, yeah, 288. Suppose another student who's in the biology stream, zoology, botany, molecular biology, and biotechnology, chemistry, and geology. There are 4 courses from zoology, 4 from botany, 2 from molecular, 3 from chemistry, and 2 from geology. So for a student who's following these subjects, selecting 1 from each for a certain semester, how many possible ways that he or she can choose the list? 4 times, 4 times, 2 times, 3 times, right? So that will be 192. See, right? So it's not going to be an easy task, right? If you have to do that. So that is why we have prepared course combinations and restricted it only to 3 subjects, right? So otherwise, it will be very, very hard to prepare timetables, allocate time slots, identify lecturers, and so on, right? Okay, now you know the reason for restricting the course combination for 3 subjects and offering few of those. Okay. So do you have any questions up to here? Do you have any questions up to here, what we have done so far? Multiplication rule for k steps with n1 up to nk possibilities, right? Everything clear? So just think about situations where you'll be using it. So here's another way. Here's another question, a different one, right? In how many different ways can a student answer all the questions of true false containing 20 questions? True false, so only 2 possible answers, either true, either false. For 20 questions, how many different ways answering? 2 multiplied 20 times, this many different answers. See how huge it is, right? This many different answers for true false, right? So if you had multiple choice with 4, how many will be there? Okay, so I'd ask question. We are getting 1 from each. But if we go more than 1 from each, that is where we have the combination and permutation, right? So that's our next step. Yes. So the first one, we learned the multiplication rule or the basic principle of counting, which is selecting 1 from each. So the next topic, that's what we are going to do next time. If we have to select more than 1 from each, that is where we do combinations and permutations, right? So that's what we are going to learn in our next lesson, right? So that question will be the best place to stop for today, right? So we'll continue with permutation and combinations. That's where we are going to select more than 1 from each group, right? So all possible ways that you can do those type of selection, right? So it's 8:50 now, so I have to finish the online session. I will share this note set with you, okay? And the recording, let me know what is the way you prefer, right, to upload the recording. So do you have any other questions one last time? Yes, the Learn Statistics is my YouTube channel. Thanks for reminding it. Let me share the link with you.
Helen Hansel was able to win any competition she took part in. She was
Okay, so here's the link for the chapter 1, actually the one I did today, right? The lesson that I started today, right? So that contains in my Learn Statistics is the YouTube channel, right? It contains this course. It's named as ST102 because that was the old course combination name and the course code. And it has all the chapters there, so you can refer to it before you come to class next time, or you can look at it leisurely, right? Okay. And there are many other videos from other chapters, other courses I do in other universities and other faculties. So don't worry much about those courses. Just refer ST102 and ST201. Okay, then shall we stop for today?